ATIS, at its heart, is aimed at trying to understand and answer the question, how much does asymptomatic TB, which is TB in a person who doesn't have one of the classic TB symptoms, how much does that contribute to transmission? Because if we can answer that question, and it turns out that asymptomatic TB does contribute to quite a lot to TB transmission, it means we're going to have to redesign the public health approach to TB and commit as a world to the idea of TB screening among people who don't have symptoms. If we find that asymptomatic TB does contribute significantly to transmission, then there's a whole lot of other questions. And ATIS takes the opportunity to try to answer those as well at the same time. So a really important one is, if we are going to screen for asymptomatic TB, well, how do we do it? So we have a couple of very leading tools in the current environment. Those are digital chest x-rays assisted by AI reading technology. Those are sputum collection, which has been the gold standard for many years now. But there's some exciting new tools, like using tongue swabs that can be analyzed right there in the community when you're doing the testing. There's the potential that something like a face mask, which captures the exhaled air, could be helpful. So ATIS will also try to address how well those tools perform in asymptomatic TB and to see if they could be helpful in screening. And then another important question, and this is really important to the members of the community and the people who may be diagnosed with asymptomatic TB, is, well, how sick am I really? And will treating me help me maybe not develop the long-term complications that we know that TB causes? So understanding the true nature of the body's reactions to having asymptomatic TB is another really important aim of this study. So we'll do in-depth study of people with asymptomatic TB, with symptomatic TB, people who don't have TB, and make sure we really understand the full spectrum of this disease and how it impacts on people. And then the final component of the study, which is also really critical, is how do we take now these two big data sets from two parts of the world, KwaZulu-Natal, South Africa, Bandung, Indonesia, and how do we bring this information together and expand it to draw conclusions that will be applicable to both countries and the whole world? And that's where the mathematical modeling aim really comes in. How can we use the unique information we're gathering in this study to inform national policy as well as global policy, and to model the question to, like, well, what are we going to do about it? How can certain interventions change the TB epidemic? That's a question that we can address through mathematical modeling.